First, we start from electric field due to infinite line. So let us take a line of length infinite from minus infinity to plus infinity. We assume that charges is distributed throughout this infinite line, that the total charge BQ. And now we are going to find what is the electric field due to this charge. Okay. So if you take these are the three axes, right? Let this be, for reference sake, we will write it as X, this is Y, and this is Z. And the most important thing is here we are going to solve it using cylindrical coordinate system, right? We know what is cylindrical coordinate system. In Cartesian it is like X, Y, Z, right? Like a cylindrical it is R, Phi, and Z, right? We have already seen R is radius and Phi is the angle between X and that point, and Z is the height. Okay. Likewise, we will be defining the point in cylindrical coordinate system, right? And differential length is dr, r d phi, and dz, right? We have already seen for Cartesian it is dx, dy, dz, right? For cylindrical this is. Okay. Now let us come. We have an infinite line of length infinity actually. Okay. We are going to place it on the z-axis, right? Let us keep that infinite line on the z-axis. Let it ranges from minus infinity to plus infinity. Okay. Now I am going to find E vector at a point which is at a y. So let this be the point where I am going to find electric field. So since it is a infinite line, I am going to take a differential length, right? A small length, let it be dl. Okay. So the coordinates of this point are, we know, since it is on z-axis, one thing we are sure, radius will be 0, right? Phi it may be any value and z may be any value. I am placing it at a random point, anywhere in that axis. But one thing we are sure that since it is on the axis, radius will be 0, right? And similarly, if you take in this case a point, it is also placed at random, right? So it is at some radius phi r, at some angle phi, but since it is on the axis, I can say height is 0. Okay. If you place anywhere, we can place it here or here, where anywhere you place, r should be some value, phi will be some other value, and but since it is on the plane, 0th plane, okay, z will be 0, right? So we have found the two coordinates. So let us draw a line connecting these two. Since we have already told that charges line should be drawn always from charge to point. Right? One point we have to remember is line should be drawn always from charge to point. So this is the charge, right? This is infinite charge. I am taking a differential length of the charge. I am going to draw a line from charge to point. So the arrow points from charge to point. So this is what R. Okay. And we know this is radius and this is z height. Okay. Right. Let us write the equation E equal to, we know the equation Q by 4 pi epsilon R square AR cap. Right. Since I am using only a differential length, the charge which is present in the differential length is dq, right? Dq. So I am going to write like this, dq. When this becomes dq, the equation becomes de, right? For differential element, right? We integrate de to find e, fine? Okay. So dq We have already seen just now, right? Rho L is nothing but Q by L. Then dq dl, right? What is dq? Rho L dl, right? What is q? Integral of rho L dl, right? So instead of this dq, I am replacing it by rho L dl. You may ask a question, okay, why rho L? We can use rho S, ds, rho v, dv. That depends on the type of charge. If the charge is in the form of a line, we have to use rho L. If the charge is in the form of sheet, we have to use rho S. If the charge is a volume charge, we have to use rho v. Okay. Since here it is an infinite line, we are using rho L dl. Okay. So dl, if you take dl, there are three things. Yeah. One is dr, r d phi, or dz. Again, it depends on the direction of the charge. If the charge is in the form of a ring, we will be selecting this, right? Here the charge is in the form of a straight line, and also it is along the direction of z. I am choosing dz, right? Charge is in the form of a line and it is along the direction z. So dl is replaced by dz. So the equation becomes rho L dz. Okay. Now we can replace it by this equation in place of dq. So dE becomes rho L dz by 4 pi epsilon r square ar cap. Now the next thing is we want to find what is r. So find r vector. R vector is nothing but ending point minus starting point. This is the starting point, this is the ending point. Ending point minus starting point. So what will be the case? R AR, 5 minus 5 is 0, minus Z A Z. What is modulus of R vector? Root of R square plus Z square. To substitute all these things in this equation, DE becomes rho L divided by 4 pi epsilon r square. R square is nothing but r square plus z square multiplied by AR cap. What is AR cap? Given vector by modulus of that vector. Okay, this is the case. Now I have left some place for dz. Okay. What is dz? What is z? Now I am going to find E. E can be found by integrating these things, right? From this we are sure that z is a variable, so going to substitute for z. Z is nothing but limit for z is, since it is infinite line, z limit is minus infinity to plus infinity. Okay. Another one we can see, it is an symmetrical diagram, right? Whatever charge is present above this will be same present below. Okay. So these two charges Fx will be cancelled at this point. Okay, since there are equal amount of charges in above and below of the symmetry. So the effect of Z, that is this part, will get cancelled. So the equation now becomes integral z equal to minus infinity to plus infinity rho L dz r AR divided by 4 pi epsilon r square plus z square. Here we can say it is power 1. Since it is root, it has power 1 by 2. So 1 plus 1 by 2 is 3 by 2. 3 by 2. Now we are going to solve this, right? I'll tell you a tip. If dz, which is variable, if it is present within this bracket, right, power of 3 by 2, which is, we have to go for substitution. When we have to go for a substitution, variable should be found inside this power bracket. Okay. Now I am going for substitution. You take this triangle, right? I am taking this triangle, same triangle here. We know this is R, this is Z. Let this be theta. What is tan theta? Tan theta is nothing but Z by R. What is theta then? Theta equal to tan inverse Z by R. When Z equal to minus infinity, if you substitute this, theta will be tan inverse of minus infinity, which is nothing but minus pi by 2. When Z is equal to infinity, theta becomes tan inverse of infinity, that is pi by 2. And what is Z? Z equal to R tan theta. I want to replace its Z, right? So I want to find dz. You differentiate this Z, dz, it becomes R secant square theta d theta. Okay. With these all inputs, we will be replacing this C vector equal to, Z will become theta. Theta equal to, instead of minus pi by 2, instead of minus infinity, it will be minus pi by 2. Instead of infinity, it will be pi by 2. Rho L. What is dz? R secant square theta d theta, right? Here on R is there, so R into R square AR cap divided by 4 pi epsilon R square plus Z square, R square tan square theta whole power 3 by 2. So I am taking things outside. Rho L R square secant square theta d theta AR cap divided by 4 pi epsilon. If I take R square outside, R square power 3 by 2 is R cube. 1 plus tan square theta is secant square theta. Secant square theta to the power 3 by 2 is secant cube theta. Right? I'll explain once again. If I take R square outside, it will be R square to the power 3 by 2. R square to the power 3 by 2. So 2 and 2 will cancel, it will become R cube. In similar way, 1 plus tan square theta is secant square theta. Secant square theta power 3 by 2 is secant cube theta. Okay. Now this R square and this will get cancelled. Secant square and the cube will get cancelled. Okay. Now it becomes E vector equal to integral of theta equal to minus pi by 2 to plus pi by 2 rho L AR cap divided by 4 pi epsilon R. 1 by secant theta is cos theta, right? Cos theta. Now you take all these constant outsides, divided by 4 pi epsilon R. You integrate cos theta and substitute this, you will be getting say 1 by 2 and 1 by 2 it will be 2, right? So this 2 and 4 will get cancelled. So the expression of E vector will become rho L by 2 pi epsilon R AR cap. This is the final expression of electric field due to infinite line charge. Right? Let us explain this. If I take a line charge, and I have taken a point here. The E vector at this point will be equal to rho L, that is line charge density of that infinite line divided by 2 pi epsilon r constant, right? R is nothing but, this is what R, right? It is the perpendicular line drawn from charge to point. This is a perpendicular line drawn from charge to point. So this is how the equation we have derived, right? This is the equation for E vector due to infinite line of charge. Okay, we will see the problems related with that expression. Now we are going to solve a problem related with line charge, right? We know electric field due to line charge formula is rho L by 2 pi epsilon r A r cap, where r is perpendicular distance of charge from point. Okay, I'll have a, we'll solve a question, right? We have a line charge of density rho L equal to 25 nanocoulomb per meter. The line charge is at x equal to -3 and y equal to 4 meter. Question is find E at 2, 3, 15. I will repeat the question. We have an infinite line of charge density 25 nanocoulomb per meter. The line is situated at x equal to 3 and y equal to 4 meter. You are asked to find electric field at this point. Okay. Clearly we can say x and y, right? The problem is in Cartesian coordinate system. So 90% these type of problems are in Cartesian coordinate system. Right? So we'll be drawing, right? Let this be x, this be y, this be z. First thing is we want to find the direction of the charge. Charge is in along x-axis. We don't know y, or it may be z. Okay, charge, the line may be parallel to x-axis, or may be parallel to y-axis, or may be parallel to z-axis. How we have to find is, if x and y are given, right? X is constant, x equal to 3, y is also another constant equal to 4, means the only variable is z. So we come to a conclusion that line is along z direction. Right? Suppose if the question is given as y equal to 3 and z equal to 4, now y and z are constant and the variable is z, x. So we will come to a conclusion that line will be along x-axis. Right? In my question, right, it is x and y are constant, so the line is along z-axis. So we can write, okay. If we take anywhere in the line, x will be 3 and y will be 4. Okay. Now we are asked to find electric field at a point. Let us assume the point is here. You don't want to be precise in pointing all these things, right? 2, 3, 15. As per the formula, rho L it is given. 2 pi, these are a constant, right? 2 pi epsilon are constant. The only thing you have to find is R. R is nothing but radius from charge to that point, right? So I am going to draw a perpendicular line from charge to this point. I will be going to find R. For finding R, I need to have this point also, right? Coordinates of this point also. We know anywhere in this line, x is constant, y is constant, and z is variable, right? Z we can directly copy it from here, because since it is a perpendicular line, the point will be situated at the same height of that a point in charge, right? So the thing is 3 and 4 are constant is given in the problem itself. This 15 we can copy it from that point. Okay, since they both will be in same height. Okay, now we find R. What is R vector? Ending point minus starting point. Now another thing we have to conclude is direction, right? We have already seen the direction is always from charge to point. So this is the direction. So ending point minus starting point. So 2 minus 3 ax, 3 minus 4 ay, 15 minus 15 is 0, right? So R vector is nothing but minus ax minus ay. What is R? Root of 2, right? Substitute all these things in this equation. So E vector equal to rho L. Rho L is given as 25 nano coulomb, right? Nano is 10 power minus 9 divided by 2 pi. Epsilon is 8.854 into 10 power minus 12 multiplied by R. R is nothing but root 2. Okay. So we can find the final answer. It will be 86.42 AX plus 17.28 AY. So only thing we have to know here is line will be always starting from charge to point, and this line is nothing but a perpendicular line. So this 15 will be same as this. Okay, the height will be equal in both the directions, right? So the height will get cancelled. 15 minus 15 will be 0, right? This is how we have to solve a problem for infinite line. The next derivation we are going to see is electric field due to circular ring. Circular ring of charge. This derivation also we are going to solve using cylindrical coordinate system. So R, phi and Z, and differential parts are dr, r d phi and dz, right? You remember all these things. Here the charge is in the form of a ring, right? Charge is in the form of a ring. A ring is nothing but a line which is in the shape of a circle, right? So here, what is the charge? It is again a line charge. Okay. So whenever ring is given, ring is nothing but line charge. Sheet, if you take a sheet, it is surface, right? Ring is line and sheet is surface. Okay. So here ring is given. So we will be placing that ring in this xy plane. Let the total length be L. I will be taking a small length of this line. That will be dl. Now I am going to find electric field at the center of or any point in z axis. Okay. So here I have placed this ring on the axis and I am going to find electric field on that z axis at any point on z axis, right? In similar, we follow the last derivation, right? Now the coordinates will be, it will be at a distance of r, any angle phi, but damn sure it is on the xy plane, right? So z will be 0. If you take here, since it is on z axis, radius will be 0, remaining things will be present. Now if I draw a line connecting this charge and a point, the direction will be charge to point. Where is the charge? Charge is in the form of a ring. So the arrow is from top to bottom. Right? I have placed this ring on the z-axis and in ZY plane, right? With a radius of r. The point I am going to find E vector is on the z-axis at a distance of z. Right? Now I am going to find E vector at this point. We write the equation, general E equation, q by 4 pi epsilon r square ar cap. This is general equation, right? So this is dq, this will be de. Q is nothing but rho L equal to Q by L. Why L? It is in the form of a ring, so it is a line charge, so L. Right? So if I put dq, it will be dl. So dq equation will be rho L into dl. dl will be one among these three, right? One among these three. How will you select one? By seeing the charge shape, right? Charge where it is placed, it is in the form of a ring. If you travel along this ring, the direction will be phi, right? If you travel along this ring, direction will be phi. If the ring is in the form of a line, in the last case, it is on z-axis. If you travel along this charge, it will be in z. So we have taken dz. This case, when we travel along the line charge, the direction is phi. So rho L into dl. dl will be r into d phi. So rho L r into d phi. Since r d phi is a term corresponding to phi, right? Now we find r. R vector is nothing but ending point minus starting point. This is ending point. So 0 minus r ar plus z a z. What is r? R is nothing but root of r square plus z square. To substitute everything in this equation, dE will be equal to dq. dq is nothing but rho L r d phi divided by 4 pi epsilon r square. R square is r square plus z square into ar cap. Ar cap is nothing but minus r ar plus z az divided by root of r square plus z square, right? So here, if we say the symmetry, since it is a form of a ring, it is symmetry along r direction, right? So since it is symmetry along r direction, we can cancel the effect of ar, right? So now this becomes rho L r d phi z a z cap divided by 4 pi epsilon r square plus z square. 1 plus 1 by 2 is 3 by 2. Now which is the variable here? D phi, right? So if I want to find E, I will be differentiating with respect to phi. Limit for phi is 0 to 2 pi. It is a form of a full circle, right? Now do I want to go for substitution? The answer is no. Why? If phi is trapped inside this term, we will be going for substitution, right? It is no phi term, so it is easy to do the integration. Except d phi, all things are constant, right? You take outside all of things. So rho L r z a z cap by 4 pi epsilon r square plus z square whole power 3 by 2. integral dl, integral d phi. Integral d phi is phi. You substitute the limits. So what is the final expression? It will be 2 pi. So rho l r z a z cap divided by, right, multiplied by 2 pi, right? Multiplied by 2 pi means 2 phi and phi will get cancelled. Epsilon r square plus z square whole power 3 by 2. This is what the expression of. Right? Let us assume if this point is on the center of this ring, right? Now we have a ring here, right? Same thing. Instead of a point here, I'll be here having a point in the center of the ring itself, right? What is the formula for E? We can derive it rightly from here, right? So since Z is 0, right? Z is nothing but this part, right? This height is Z. Since Z is 0, what we have to do? This is 0 and this will be also 0. So the whole thing becomes 0. Okay. Okay. So at the center of the circle, the electric field will be 0. This is the next derivation. Electric field due to infinite sheet of charge. Infinite sheet of charge, right? Here also you are going to find this electric field formula, especially in cylindrical form, right? So cylindrical we know R phi and Z, and differential elements are dr, r d phi and dz, right? So as for the old derivations we have already seen, the same way we have to derive here also, right? The same diagram, right? Here the sheet is of infinite length, right? Sheet means it is surface, and it is of infinite length means it is placed in, let us assume it is placed in same xy plane. This is infinite, right? Infinite distance. Okay. Since it is a sheet, we are going to solve it with surface charge density, right? Rho s, first difference, right? Rho s is nothing but q by s, dq by ds. Okay. Then what is dq? dq will be rho s into ds. Okay. Here ds is surface area, right? Since the sheet is along this xy plane, okay, we want to find the direction of the plane. The direction of the plane is, if you draw a perpendicular to that plane, it is showing z. So the sheet direction is along z, right? If it is along z, you can put it as ds is z. How to find ds is z? You remove that ds component alone, z component alone, you multiply remaining things, right? So the equation becomes rho s. If you leave this thing, you multiply these two, r dr d phi. Okay. Humbly conclude that this is z direction. You draw a perpendicular to that plane. If you take any plane, let us take this is the plane. If I want to find the direction of the plane, you draw a perpendicular to that plane, right? If I draw a perpendicular, it is showing z direction. So the direction of the plane is z. If the plane is in this direction, you draw a perpendicular, it is showing x direction, right? Similarly, you are going to find. So we have found what is dq. The old formula, E equal to q by 4 pi epsilon r square ar cap. If it is dE, this will be dq, right? So dq means the whole area is having charge q. I am taking a small area of that. Let that area be dq. It is situated at radius r, phi, and z will be 0. Why z will be 0? Since the sheet is on xy plane, it will be 0, right? Let us assume this is the point where I am going to find electric field. In this point, radius is 0, remaining things will be present, right? Now I am going to draw a line connecting charge to point. Since charge is on the sheet, I am going to draw a line from sheet to that point. This is what we call it as R. Right? This is similar, in similar way what we have already seen in previous derivations also, right? Same things. Okay. So here, what is R vector? Ending point minus starting point. So 0 minus R, so minus R, A R cap, 5 minus 5 is 0, plus Z, A is Z cap. What is R? Root of R square plus Z square. Okay. You substitute all these things in this equation. dE will be equal to dQ. dQ is nothing but rho S R dr d phi divided by 4 pi epsilon. What is R square? R square plus Z square. AR cap is nothing but minus R AR plus Z AZ divided by root of R square plus Z square. Now we are going to check the symmetry. Since it is a sheet, here also the same thing, right? So AR cap term will get cancelled out. Okay. Since the symmetry is along R direction. So if I get cancelled, what is the final expression? dE will be equal to rho S R dr d phi Z A Z cap divided by 4 pi epsilon R square plus Z square whole power 3 by 2. Right? Here, what are the variables present? There are two variables, right? One is R, another one is phi. And the limit for phi is 0 to 2 pi. What is the limit for R? R is from minus infinity to plus infinity. Right? No, it is from 0 to infinity. Am I right? Since it is from here, we have to find the direction, right? So this is cylindrical coordinate system we are forming, right? In cylindrical coordinate system, or for radius, the minimum is 0 and the maximum radius will be theta. So the limit is from 0 to infinity. Okay. Now, do we want to go for substitution? As we already said, if any of the variable got trapped inside this part of the equation, that go for substitution, right? Yeah, we can clearly see the R got trapped inside that, so we need to go for substitution. What is the substitution we can go is R square plus Z square equal to, let us assume it is U square, right? Now you differentiate, 2R dr is equal to 2U du. R dr equal to U du. Okay. When R equal to 0, what is U square? When R equal to 0, U will be equal to, when R equal to 0, U square equal to Z square, U equal to root of Z, right? And U will be Z. R square is 0 means U square is equal to Z square, U equal to Z. Okay. When R is equal to infinity, in R is equal to infinity, infinity plus Z square is infinity. Infinity, you take root, this is also again infinity. Okay. Now you substitute everything in this equation. Instead of R, you will be taking U, right? 0 to infinity, it will become u equal to z to infinity, and phi will be same 0 to 2 pi rho s r dr. You can replace this r dr by u du d phi z a z cap divided by 4 pi epsilon r square plus z square is u square. We already given, right? U square to the power 3 by 2 is u cube. So now u equal to z to infinity rho s. You integrate this d phi, it will become 2 pi, right? U du into 2 pi z a z cap divided by 4 pi epsilon u cube. So this 2 pi and this will become cancelled. This will be 2. So the expression will be rho s z a z cap divided by 2 epsilon z equal to z to infinity. This u and this will get cancelled, so u power minus 2 if you solve this rho s z 2 epsilon minus 1 by u z to infinity, this will become 1 by z. So rho s z by 2 epsilon 1 by z, that z and z will cancel. So electric field is equal to rho s by 2 epsilon a z cap, right? Okay, so this is the final expression for electric field due to infinite sheet, right? Here again we'll see in our example the point is like this, right? The sheet is here and this point is above that sheet, right? You can see it from this diagram, right? In this case we have got a answer like this, right? If the point is below the sheet, if the point is below the sheet, the equation will become rho s by 2 epsilon minus a z cap. If you solve it, you'll be getting the same thing, right? So we can generalize this equation, right? How means E vector equal to rho s by 2 epsilon a n cap. What is a n cap? A n cap is nothing but the direction from charge to point. If you take a sheet, you place a point anywhere in the sheet, right? Below or above. You draw a line from sheet to that point. The direction of that vector shows the direction of a n cap. So a n cap is nothing but normal vector drawn from charge to point.